picture this. You open your inbox, and there's a glowing, literal burning invoice from OpenAI. Like a $4,800 bill shock for the month.
Yeah, that is a rough way to start the day.
Right. And for the tech founders and CTOs listening right now, if you are scaling autonomous AI agents, that image is probably giving you palpitations. So welcome to the deep dive. Today we're looking at a breakdown of the 2026 AIOps crisis, specifically, how to stop AI agent token bloat and cut inference costs by 80%.
Which is a massive deal right now because the root cause outlined here, it isn't that your AI models are underperforming, it's actually that the underlying architecture is just wildly inefficient.
I mean, they mentioned multi-step agent loops where one single user request executes up to, 15 raw LLM calls?
Exactly, up to 15, just for one single prompt.
It's crazy. And the report points out that teams are sending 100% of that traffic, so recalculating answers, running redundant formatting tasks straight to flagship models like GPT-4o or Claude 3.5 Sonnet. It's like hiring a PhD to sort your daily mail.
That is a great way to put it. It's a total overkill, and it just burns right through an operational budget.
So moving to pillar 1, dynamic model routing, we need to stop sending everything to the PhD, right?
Right, exactly. Setting a massive trillion-parameter model as the default for an entire workflow is a huge financial trap. Instead, you can route simple, repetitive tasks, things like JSON extraction or basic intent extraction, to small language models.
SLMs, like Llama 3.8b.
Yeah, exactly.
Because looking at the math here, an SLM costs roughly 5 to 15 cents per million tokens. Meanwhile, the flagship model runs you $2.50 or more. But there's a trade-off mentioned, right? A latency tax.
There is. So if the system has to stop and think about where to send every single prompt, it does add about 10 to 15 milliseconds for that routing logic to execute.
Does that slow everything down too much?
Well, to manage it, the author recommends setting a strict 90% confidence threshold. So the algorithm evaluates the prompt, and if it isn't 90% sure the smaller model can handle it, it just bypasses the SLM and goes straight to the flagship.
Okay, got it. So now moving to pillar 2, prompt and context pruning. Because even when we route to a cheaper model, aren't we still paying a fortune if the prompt itself is, thousands of words long?
Oh, absolutely. That is where token bloat gets exponential. In multi-agent loops, by step 5 of the sequence, systems are often resending the entire system prompt.
Plus all the tool definitions and the whole chat history.
Right, you end up paying for a $6,000 token payload repeatedly for just one interaction.
That is wild. It sounds like the system is essentially suffering from short-term memory bloat. Can we just force it to forget older steps?
You can. First is system prompt stripping, where the code dynamically drops unused tool schemas once an action is picked. Then there's boilerplate removal to filter out repetitive markdown or error traces. And finally, sliding window memory.
Okay, explain that one.
So the system maintains a rolling window of only the last 3 to 4 turns and compresses earlier interactions into a 50-token summary state.
Wait, I have to push back on that. Squashing a rich chat history down to 50 tokens, doesn't the agent completely lose the thread of a complex task?
It's a really common concern, but you have to separate the data from the objective. The memory isn't storing the actual documents. Those are held in separate databases.
Oh, okay.
Yeah, the 50-token state just distills the past into core objectives. The agent doesn't need the exact wording of a greeting from 5 steps ago. It just needs the instruction, like user wants a summary of Q3 financials.
That makes total sense. Keeping the goal, dropping the transcript. So moving to pillar 3, semantic caching. We shrunk the payload and routed it. What happens when users inevitably ask the exact same question again?
Well, processing the exact same question twice is a complete waste. But traditional caching fails because people phrase things differently.
Right, because traditional caching looks for exact text matches.
Exactly. Instead, a semantic cache uses tools like Redis or Qdrant to convert queries into vector embeddings. The system then measures the distance between these coordinates using a cosine similarity score.
And if the new question hits a similarity threshold of, about 0.88, the system knows it's functionally the same question.
You got it.
I'm looking at the ROI numbers here, and they are incredible. A direct LLM call might take 2,500 milliseconds and cost 1.5 cents. But a semantic cache hit takes 15 milliseconds and costs a fraction of a cent.
And you can intercept 30 to 60% of repetitive traffic this way.
But there is a strict warning here about doing that.
Yes, a massive warning. If you deploy a semantic cache, you absolutely must isolate your cache namespaces by user ID.
Or else you get catastrophic data leakage.
Exactly. The system might think two queries are semantically similar and hand user A a cache response filled with user B's private data.
That would be a nightmare. Definitely do not skip the namespace isolation. But bringing all this together for our outro, it really shifts how you view AI operating expenses.
It really does. The central thesis of the whole report is that inference cost is an engineering constraint, not a finance problem.
Right, you can architect your way out of it. And the author left a great resource at istartfromzero.com. You can download all their pre-built NA and make automation templates for free.
Yeah, you can just grab the cost optimization blueprints, routing logic, and vector cache nodes. It is an incredible shortcut.
It really is a great way to stop the bleeding on those API bills. But I want to leave you with a provocative thought to chew on. If semantic caches become so efficient that they intercept 60% of your traffic with past answers, at what point does your cutting-edge AI system stop being an intelligent agent and just become a static search engine regurgitating its own old thoughts?